Hi everyone, my name is Ritvik Sardana and I work at Frappe as a software engineer. I'm the product owner of Frappe Help Desk. So for those of you who don't know what Frappe Help Desk is, Frappe Help Desk is an open source ticket management system which has features like managing your tickets with ease, SLAs, knowledge base and much more. So it's built on top of Frappe framework in the backend and Vue.js in the front end. And the one thing which really fascinates me while working with Vue.js is how the reactivity system is handled in these framework, right? So one day I thought, let's dig deep into how this reactivity system works, and that's what I'm going to discuss today. I'll be building a reactivity system from scratch so that you can understand what reactivity is and how you can build your own reactivity. Okay, so yeah, that's what I was saying. I will be building the reactivity. And a quick raise of hand, like how many of you know that how the deep internals of reactivity works in framework like React.js or Vue.js? Okay, so not many people. So I hope this session will be insightful to you all to understand the reactivity. So let us take this example. So we have this price variable and the quantity variable. Now we calculate the total by multiplying these two, and then we console log the print the value, and then we get 200. Now we update the price to 15. We print the total, it still is 200, and that is what is the expected behavior in JavaScript, right? So how do we get the updated value? We recalculate the total by this formula, and then we print it, we get the updated value. So now, what if this system was reactive? So as soon as I update price variable to 15, you will see that the print value is automatically updated. So in this scenario, we were able to figure out that total variable is dependent upon two states, which is the price state and the quantity state. And as soon as one of them changes, the total automatically updates. So now, what is reactivity? It's magic. So it seems unbelievable to me like how amazing it is being implemented in frameworks like React and Vue. Like you change one value and it gets updated wherever it is being accessed throughout our DOM or our script, no matter what it is. Let us take this example. This is a feature of custom views in help desk. So you can create your own views and you can pin them to the sidebar. So as soon as I do it, it automatically comes on the sidebar and I can remove it also from here. So without even reloading the page, the state is automatically maintained and it gets updated automatically. So that is what reactivity is. So now let's start, building this reactivity system from scratch so that you can also implement this and understand the deep internals of it. Works. Hello. Hello. Yeah. So, so here you can see that I have this custom script HTML, and I have just written this S3 class, and I have imported this script index.js. So let us see whether this script works or not. So let us just see whether the hot reload works or not. Yep, it works. So now let us take this example. So let us say we have this object of item which looks something like this. Let's try to calculate total from this object. Same example. We'll say item.price into item.quantity. We print the value, we get it as like 20, which is the expected thing. Now we update item.price to 200, and now when we console log it, you will see it's still the same value. So to recalculate, what I'm going to do is add this formula over here again, and then console log it, it gets updated. And now same thing, just with quantity. If I do it at 5, then again I have to do the same thing, right? I copy this and you see it is being updated. So to make it a bit better, what I can do over here is I can say create a function of update total, and instead of doing it again and again manually, we can just call this update total function. So you see it is working, but now you will see it is kind of a flaw, because we have to manually track that whenever the price variable changes or the quantity variable changes, just run this function. So what if there was a way to automate all of this? So whenever we are updating any value, the quantity variable or the price variable, this function automatically runs. So that is what we are going to build today. So here I will try to make this object as a reactive object. So how I am going to do it? I am going to wrap it in a reactive function. So I get this error as, okay, reactive not defined, that's okay. We will just say function reactive. Now this function takes one argument, which is the object itself, this target object, which we are trying to make as a reactive object, right? So we'll get this. We'll just see, cannot read properties undefined. So we can just return this target object. So now everything works as expected. Now in this, I want to track that whenever this object is being called, like whenever this object is being accessed, in this object, I want to track that the quantity and the price properties are being accessed throughout our script. So no matter what script it is, we are accessing these two properties from this object. So for that, I will have to introduce a proxy. What proxy is basically is a concept in JavaScript. It is an API which was introduced in the ECMAScript 2016, and this API takes two arguments. First is basically this object, and second is the handler. So I'll be coming back to this. So let us understand what proxies are. So now proxies in JS. So we try to print the value item.quantity. What usually happens is we take the value from the object and then print it. But what if we had a proxy around it? So what it does is, instead of printing the value whenever we do item.quantity console.log, it goes to the proxy and then it tries to retrieve that value from the object. Now the main thing about proxy is it returns us the same object, but it has some additional functionalities. Like for example, we are doing a get op function over here, right? We are doing item.quantity. So proxies allows us a way to intercept these get functionality or the set functionality and add our own custom code over here. So you can see over there that we have a getter function. We can add our own custom code and return the item.quantity itself. Now similarly, when we are trying to set a variable, let's say item.quantity equals to 2, with proxies it's kind of similar, that whenever we do item.quantity equal to 2, we will create a proxy from the object of the item. It will try to retrieve that value from the object, and while sending us back the value, we can add our custom code in the setter object. So let us try to build towards that. So now in this handler we get many arguments. So first one is the get argument. This function returns us two parameters, which is the target, again this object, and the key which we are trying to access over here. So now let us see, we are saying that accessing this key. So we will see we are accessing price, quantity again and again, because that is how it works. So accessing price, accessing quantity. But now let us try to console log it. You will see we get this nan, and why is that? This is because we have overridden the native functionality of a object get operation in the object. So to get back that native functionality, we will just return target key, and now everything is like back to basics. So here now we are able to add our custom code while even fetching a property from an object, and that's the magic behind proxy. So now I have to track that inside this object, whenever quantity property changes or price changes, just run this update total function automatically. So I need to store it somewhere so that I can refer to it whenever the let's say price is being changed, so I can refer to it. So we need a central data store somewhere so that I can store all of this. So for that I am going to introduce a variable of target map. So let us keep it as an empty object right now. So for that I will say track dependency. So this function, I'm going to create a new function, target key. In just a minute I'll show why I'm doing this. So here we can say that we are able to track any particular key which is being accessed from this object. Tracking key. Yep, we are able to track it. So now we need to store it somewhere. So for that I will introduce this a variable called target map, which is a empty object in the initial state. So now let us try to make this data structure so that we can store the object, the properties, and the function we want to run whenever this properties changes. So for that I'll say target map target is equals to key, and let us try to console log, print this value. So you will see we get this weird notation of object. So like even if I do over here, instead of this, if I do item dot quantity, you will see we get this weird notation. So why is that? This is because whenever we try to store an object as a key in another object, so in this case this is the empty object and we are trying to set this item object as a key so that we can track this particular object. So what JavaScript does is it tries to convert it into a string. So let us take this example. Item is an object over here. You can see it's a proxy object, and whenever we store it as a key, the JavaScript tries to convert it into a string using this method, and you will see this weird notation. So how do we solve it? We can use something known as map, and the beauty of map is whenever you store a key as a value in this, when you store an object as a key in the map, the memory reference object is stored instead of the actual object, or it is being converted into a string. So we'll go over here, we'll say target map dot set the target as key, and if I do over here, you will see that the whole object is being tracked right now. It is not even being converted into a string, and that's why we should use maps in this case. So now let us try to store that against this item object. We want to store these two properties because these are being accessed throughout our script. So over here we'll say that let dependency map is equals to target map dot get target. So now what we are doing over here is we are trying to say that find whether this object is being tracked or not. Are we tracking this object? Is this object being referred to in our script or not? So in the initial state it won't be there, right? So we'll just say if there is not any dependency map, we'll say dependency map is equal to new map. I'll just show you why I'm creating another map, and we'll say that target map dot set the target as this dependency map. So what I'm trying to do over here is I'm trying to build a data structure so that I can track that inside this object I want to track that the keys which are being accessed. So that is the first step. I have created a key with the object itself, and the value is a empty map, which is the initial state. And now here what we want to do is we need to run the function of update total whenever the price changes or quantity changes. So we say let functions to run is equals to dependency map dot get the key. So here we are saying that find me the functions which we need to run whenever this particular property changes. So we are setting the initial state, so that is not what we are going to get. So let us set the initial state. So we'll copy that. If we don't find any functions to run, so we will say functions to run equal to an empty array. I mean, we can use an empty array, but an array does not ensure us that a unique values will be stored in the array, but So to avoid these duplications of code, we can just use a set because it stores unique values. Now once we do this, we'll say dependency map dot set the key as this functions to run. So now if I console log this value, I will print this value. You will see that we are kind of building towards the data structure that inside this object. Just track this property, I don't know, quantity. Now if I do, let's say, item.price, you will see that it is being reflected over here. We are tracking this. So this means we are accessing these properties somewhere in our script. Now once that is done, so what do we need to do? When this quantity changes or price changes, we need to run the function of update total. So we'll say functions to run dot add update total. So we'll see that update total is not defined, which is okay. I think it's commented. So yeah, we can do it. So now if I print the value of target map, you will see that we have successfully built this data structure that we are inside this key object, inside this item object, track these values of quantity and price, and whenever one of these property changes, run this function of just a second, update, it's still not visible, that's update total. So we have built this data structure. Now what do we want to do? We just need to run this function whenever we are setting some property over here, like quantity or price. So now let's do it. So once we do over here, you will see it doesn't run, which is the expected thing. Now similar to the get handler, we also get set handler in the proxy itself. So this object, this function gives us 3 arguments. First one is the target, again the object which we are setting, the key which is being changed, and the new value which is the updated value. So for example, in this case, you will say that this is the target, this is the key, and this is the new value. So we'll say over here, like now try to item dot quantity. So now you will see that even doing the before thing and after updating the state of the quantity, we still get the same value. So why is that? Because here we've completely overridden the native functionality of the set operator. So what do we do over here? We just say from the target, get me this key and set its value to the new value. So now you will see it is being worked over here. So here we just need to do one thing, which is run the functions whenever this key changes of price or quantity. So for that I will say trigger dependencies, trigger functions to run, we can say that to run. Now this takes 2 arguments again, which is the target object. Inside this object, whenever this key changes, trigger this trigger all the functions. So similar to tracking dependencies, we'll say function trigger functions to run, which takes again 2 arguments, the key. Now what we are going to do is we are going to traverse through this target map so that we can find what functions do we need whenever this property changes, like we have to traverse nested into it. So yep, we need to find this function. So to do that, it's very simple. It's similar to this get handler only. We'll say let dependency map is equals to this. So now we'll say that if there is no dependency map, don't do anything. And why is that? Because in this we are referring to this item object. There can be like multiple reactive states, right? But let us set to item 2. But item 2 object is not even being accessed anywhere. So why to even track it? So that's why we'll say that if the object is not being tracked, then just don't do anything. Similarly, we'll say try to find me the functions to run against this particular key. So I'll say functions to run, and now if we find any functions, then just since it's a set, we can use the for each functionality and fn just run all the functions inside it. So now you will see something. So from here, even if I have another script, any script wherever it is, if I try to update the quantity, you will see that the total is being automatically updated, and that is what reactivity is. So no matter wherever this object is being referred, this function will run automatically and the reactive system will build. But now there is a kind of a flaw in our system, which is a very naive approach to adding this function update total to all the properties. So what I mean by that is, if I say, let's say item dot brand, you will see that even for the item brand, whenever we access this function is running. I'll show you. So you will see for let us just console. Yeah, if I am trying to say item dot brand equals to, you see this function is being run, has run again. So how do we solve this issue? Because our system needs to be efficient, it should only run this function whenever the state inside this function changes. So for that I am going to introduce a new variable, which is active function, whose initial state will be a null value. So in our script we can have thousands of functions, right? But against a property we should ensure that there should be only one active function at a time, so that it can be tracked easily. So here I'll say where is it? Yep, active function. So with that I am going to introduce watcher functionality. So what this is, so this is a watcher function which watches the changes basically. Now it takes one argument, which is the callback function. In this case it will be the update total watcher here, and we'll say that active function is equal to this callback function. Now inside the try box we'll try to execute this function no matter the errors, if there are any errors or not, and then finally we'll set the active function as null again, so that for whenever the next property accessed we can start with the initial state itself. So now instead of doing update total, I'll say watch this inside the watcher, watch these changes, and whenever one of these changes, update the total. So okay, I got an error, update total is not defined. Oh right, we need to update it with the active function. So instead of doing the update total function over here, we can just say add the active function for this particular target and this key. So I'll say active function. So we get another error, which is fn is not a function. Okay, let's try to debug it. So let me reload. So over here console, what do we get the value? We get this as an empty okay, cool. Length and arguments, this is fine. I think it's trying to run this function even if it's trying to run the active function even if it is not being tracked. So what I mean by this is, this property does not have any watcher and the active function is set to null. So we can keep a track over here that if there is no active function, then just return, don't do anything. So once we do it, in the console you will see that we are properly able to run this. Now let us try to console log print the value of map, and even if I do this over here, you will see that this property is now not being tracked because there is no watcher function for it, and we are only tracking the price and the quantity. So this is a kind of efficient way to do it. So now just replicate this in the DOM and we are almost done with it. So I have prepared a HTML layout over here. And I used Tailwind classes by using the CDN from the Tailwind itself. It is provided by Tailwind. So once I do it, you will find that we have this UI over here. Now we need to replicate the same thing but with the DOM itself. So that is very simple. So for here, we will say, so these are our input elements, and to find the value inside it, we need to have the onChange handler. So inside the HTML script, we will see that there is a function of onChange handle quantity change. So nothing I'm going to do, nothing fancy. I'm just a function handle quantity change. It gives me the event of the input element, and say item dot quantity is equal to parse int e dot target dot value. I'm using parse int because the value which is given to us by this mouse handler is in string, so we need to convert it into a number. Now similar to handling the quantity change, I'll also on change do the price change. So just replicate this. So item dot price, and now we are done with it. So this is working. So once that happens, instead of console logging it, what do I want to do is, instead of printing it in the console, I need to show it in the DOM. So for that we have this total HTML, which is have an ID of total. So just do it. So we just say document selector. Since it's an ID, we're going to use the hash, and we'll say that in text content is equals to total. So now whenever we're trying to update this, it would work over here. So let us understand what is going on over this in this issue. So this is because the initial value of this quantity and price is not being set. So so for that, what we'll say is document dot add event listener. So we have an event listener on the DOM, which is called the DOM content loaded. So in this, whenever this HTML is printed onto a DOM, we can attach an event listener and handle some cases, like for example in this case, the initial set of price and quantity input values. So over here, I am just going to say one thing. I'll just say that for this input, take this input. Again, document dot query selector price dot value is equals to item dot price. Similarly, we are going to do this for quantity. So now everything is going to work perfectly. Okay, there is some error, which is fine. Let us try to see what is wrong. Function change and quantity change. Inside this change, let us see what we are getting from here. Huh? Oh, sorry, handle price change. So now when we do it over here, you will see that we have successfully built a reactive system. So again, thank you. So wherever it is being accessed, no matter what the script is, as soon as we update item.quantity equals to like 90, it will get updated in the DOM and the input element itself, and we don't have to manually track it. So yeah, thank you so much everyone. To get the resources for this presentation, you can scan this QR code, you can get the presentation, you can get the GitHub link for the code, and you can also see some of my personal socials. Yeah, thank you.